Now we are going to solve some problem which are based on some standard result and the problem based on under square root. So the first problem is evaluate integral x into under root x raised to power 4 minus 25 dx. So here let I is equal to integral x into under root x raised to power 4 minus 25 dx. So if we see, we can write it as under root x square whole square minus 5 square. And if we see, if it is x square, then 2x dx is the derivative. So, to make the integral easy, let x square is equal to t. So, it becomes, after taking derivative, 2x dx is equal to dt. Therefore, x dx is equal to dt over 2. So, we get x dx is dt over 2 and here we get t square minus 5 square into t over dt over 2. So in this form we get 1 over 2 integration under root t square minus 5 square into dt. So we get, if you see, this is the under root x square minus a square. So what is the formula of x under root x square minus a square? So see, that is half x over 2, that is t over 2 under root x square minus a square minus a square by 2, that is 5 square by 2 log of x, that is t plus under root t square minus 25 plus c. So that is the formula used, integral under root x square minus a square. So here we get half t by 2 under root t square minus 25 minus 25 by 2 log of t plus t square minus 25 plus c. So we get I is equal to half, replacing t by x square. So we get x square over 2 under root x raised by 4 minus 25 minus 25 over 2 log of x square plus under root x raised to power 4 minus 25 plus c. So this was the problem based on standard results. You see, we use standard form of integration. So the next problem is that is evaluate integral e raised to power x into 1 plus sin x into cos x over cos square x dx. If you see, it looks like very complicated problem. Now, let's see what happens. E raised to power x into 1 over cos square x plus sin x into cos x over cos square x dx. So, if we see here, we get e raised to power x into secant square x, 1 over cos x is secant x, and if we see here, 1 cos is cancelled out by 1 power and we get sin x over cos x, that is tan x dx. If we see here, let if fx is equal to tan x, then f dash x is secant square x. So this is the form of e raised to power x f dash x plus f of x dx. So its result is e raised to power x fx. What is fx? Fx is here tan x plus c. So this is our required result. So while doing problem, we have to concentrate on the question and what is our result and which form can be used. This should be decided. Now the next problem is, that is third. Evaluate integral under root 1 minus sin x over 1 plus cos x into e raised to power minus x by 2 dx for x lying between 0 and pi by 2. So here let I is equal to integral under root 1 minus sin x over 1 plus cos x into e raised to power minus x by 2 dx. So here we are using cos 2 theta formula and sin 2 theta formula. One can be written as sin square theta. Theta may be x by 2, cos 1 something, any. Angle may be any, but it should be same. So it is x by 2, and sin x, that is sin 2x, is 2 sin x cos x. So sin x becomes 2 sin half of angle into cos half of given angle over 1 plus cos x is 2 cos square x by 2, because cos 2 theta is 2 cos square theta minus 1. So 1 plus cos 2 theta is equal to 2 cos square theta, that is a half angle, that is 2 cos square x by 2 into e raised to power minus x by 2 dx. If you get such type of form, we are always using 1 plus cos x replacing 2 cos square theta, and 1 minus cos x always replacing by 2 sin square theta. So 1 minus sin x is always replacing by such form. Replace sin x by cos pi by 2 minus theta. So I become sin square x by 2 plus cos square x by 2 minus 2 sin x by 2 cos x by 2. This is the sin a minus b whole square. So we get under root sin x by 2 minus cos x by 2 whole square, a minus b whole square over 2 cos square x by 2 into e raised to power minus x by 2 dx. So here is cancelled out by under root. We are remaining with sin x by 2 minus cos x by 2 over 2 times cos square x by 2 into e raised to power minus x by 2 dx. So here we get half is common out from the integral. Sin x by 2 over cos square x by 2. Sin x by 2 over cos x by 2 is tan x by 2 into 1 over cos x by 2 is secant x by 2 minus cos over cos square, that is cancel out, 1 by cos x by 2 is secant x by 2 e raised to power minus x by 2 dx. So if we see, this is formed just like this is a function and its derivative, but there is x by 2 creating problem. So let x minus x by 2 is equal to t as e raised to power minus x by 2. So it gives minus half dx is equal to dt. because derivative x is 1 and dt over dx would become minus half dx dt. So we get dx is equal to minus 2 dt. So we replace in the integral I becomes, that is half of secant minus t, because we have secant x by 2 it becomes secant minus t, tan of minus t minus tan of minus t into e raised to power t into minus 2 dt. Do this step very carefully. So we get I is equal to 2 is cancelled out by 2, minus is common out, we get secant of minus t is secant t, tan of minus t is minus tan t. So as tan of minus t is minus tan t, we get plus tan t. Sorry, we have here, I write wrong, we have here secant. So secant of minus t is secant t into e raised to power t dt. So minus is taken out, that is we get minus minus plus, we get secant t into tan t plus secant t into e raised to power t dt. You can see we get the same form. Here f of t is secant t and f dash t is secant t into tan t. Therefore, I is equal to integral f of t plus f dash t e raised to power t dt form. So here we get e raised to power t into ft, that is secant t plus c. So what is t? It is e raised to power minus x by 2 secant of minus x by 2 plus c. So we get e raised to minus x by 2 secant of minus theta is secant theta plus c. So this is the required result of I. So we are going to discuss the next problem in the next lecture. Now the next problem is evaluate integral x minus 5 into under root x square plus x into dx. So if we compare, this form is like ax plus b under root ax square plus bx plus c. So here let x minus 5 is equal to m times derivative of x square plus x plus n. So here we get x minus 5 is equal to m times 2x plus 1 plus n. So on comparing the coefficient, we get here coefficient of x is 1 and here 2m. So we get m is equal to half. And on comparing the constant, that is on the left hand side it is minus 5 and on right hand side it is m plus n. So we get n is equal to minus 5 minus m, that is minus 5 minus half. So we get minus 11 by 2. Therefore, n is equal to minus 11 by 2. So, we can write x minus 5 is equal to half 2x plus 1 minus 11 by 2. Therefore, integral x minus 5 under root x square plus x dx becomes integral half 2x plus 1 minus 11 by 2 into under root x square plus x into dx. That is, we say I is equal to integral half of 2x plus 1 under root x square plus x minus 11 by 2 integral under root x square plus x dx. So we take I is equal to I1 plus I1 minus I2, that is half I1 minus 11 by 2 I2, where I1 is equal to integral 2x plus 1 under root x square plus x dx, and I2 is integral under root x square plus x dx as done in the article. So first of all we are going to solve I1. As I1 is integral 2x plus 1, first of all we will give name as equation 1. So we have this under root x square plus x dx. So let x square plus x is equal to t. So on derivative it becomes 2x plus 1 dx is equal to dt. Therefore, I1 is equal to integral under root t dt. So we get t raised to power half plus 1 3 by 2 over 3 by 2 plus 3. So we get 2 over 3, that is t, that is x square plus x raised to power 3 by 2 plus 3 in case of I1. Now we are going to solve I2. I2 is under root integral under root x square plus x dx. So if we see here, we have to make it perfect square. So to this, first of all we have to make coefficient of x square 1. It is already 1. So take the half the coefficient of x. Now taking the square of this, we get 1 by 4. Half the coefficient of x is 1. So half of 1 is half square is 1 by 4. So we will add and subtract 1 by 4. That is I2 is equal to integral under root x square plus x plus 1 by 4 minus 1 by 4 dx. So from this we will get integral under root x plus half whole square minus 1 by 2 whole square. So if we see, we get the form under root x square minus a square. So the result will be x by 2, that is x plus half over 2 into under root same term, that is x square plus x. On solving we will get again this, that is minus a square by 2 log of x plus under root x square plus x plus c dash. So we get 2x plus 1 over 4 under root x square plus x minus 1 by 4 into 1 by 2, that is minus 1 by 8 log of 2x plus 1 over 2 plus under root x square plus x plus c dash. So now substituting I1 and I2 in number 1. So we get I is equal to M times. So M is, that is, we have half I1. Our I1 was 2 by 3 under root, that is x square plus x raised to power 3 by 2 plus 3, and we have minus 11 by 2, and I2 is 2x plus 1 over 4 under root x square plus x minus 1 over 8 log 2x plus 1 over 2 plus under root x square plus x plus c dash. So we get as a whole, that is, I is equal to 1 by 3 x square plus x raised to power 3 by 2 minus 11 over 4, or we can say 11 over 8, we can take out. That is, we will have in the bracket 2x plus 1, because 4 is come out, under root x square plus x, as 8 is come, 4 is come out, here we will remain with 1 by 2 log of 2x plus 1 over 2 plus under root x square plus x plus c double dash, where c double dash is c plus c dash, constant of integration. So it was the integral value of under root x square plus x into x minus 5 dx. So here we learn how can we make the perfect square, and to get the form under root x square plus a square, or x square minus a square, or a square minus x square under root. So by getting these values we can use these formulas. So we see all this in this question.